Good morning and welcome everyone to this plenary session on grid security and new technologies. I'm Luciano Martini. I'm with RSE. RSE is a national research center based in Milano, Italy. And RSE is very active on grid security and new technologies. And in particular, my department is dealing with technologies and new components and devices for the grid security and the grid resilience. I think it's never been so important grid security as in these days. You know, the grid is a critical infrastructure for a country and need to be available at all times, 24/7. And this is why we need to make sure that we have a grid that is well maintained, is also well protected against major threats. And when I think about threat, I think about extreme weather events. I'm also thinking about aging of major components, but also to cyber attacks or everything related to cyber attacks. I had the pleasure to contribute to this session also in the past, both a physical session in Rome or virtual session as today. And today I have a great pleasure to share a session with the three distinguished speakers that will share their view and their expertise on grid security. We'll also bring in some example of new technology to be applied in order to enhance grid security. I think we will have time for listening these three very nice presentations from the three speakers. Each of them will have 15 minutes for making its point and touching this important aspect. Then at the end of the session, we will have also the possibility to take one or two questions from the audience. So please try to write down in the chat box any comment or any question you have for the speaker. We will try to deal with them during the session. If not, we will try to reply to you remotely by email. So I'm ready now to start with the session. So here you see the three speakers, Salvatore Pinto, Massimo Salvetti, and Simone Botton. And as I said before, we are very much concerned about extreme weather events. And you see here some title from newspaper about the major event that happened in our system in Italy elsewhere. And here's also some picture about some of the extreme events that we are experiencing these days that before were not happening so often, but now the number of these events is really increasing, also related to climate warming and other effects related to climate change. You know, grid security. So grid security, as I said, still related to extreme weather events, but also to cyber attack. I hope some of the speakers will also address this topic, but it's clearly important, especially in these days. And after this short introduction, I think I will be very pleased to give the floor to Mr. Salvatore Pinto, that is president of Axpo Italia, that will be making a presentation and contribution as grid security and the role of storage. So Salvatore Pinto, the floor is yours, and I stop sharing my screen now.
Thank you very much for the invitation. I'm the chairman of Axpo in Italy. Axpo is one of the major utility in Italy, but also in Europe. It's owned by the Swiss cantons in German language and is present in 30 countries, mainly in Europe, but also United States and Singapore. Then obvious that when we are speaking about grid, we need to speak about the changement, the climate change, the big effort that everybody is doing with renewable energy as photovoltaic, aeolic. That's together with the automotive, electrical automotive, is creating a new environment. It's clear for everybody that the renewable energy is unpredictable. That's create a lot of trouble in the grid because it's stressed. In some cases, we have a peak of energy. That is also a peak in the price. So in some cases, the energy will become, the price of energy will become negative because we have more energy that you are able to to dispatch in the grid. In other cases, the contrary. That means that renewable that is necessary to reduce our emission in terms of CO2 will create other kind of a problem. If you add this kind of issue, also the automotive, that means electrical car. You can imagine if 10 huge cars will arrive all together in a service area, they need to recharge, they need more or less, we are speaking about 300 and more kilowatt of power. For 10 is 3 megawatt that you need in 8 minutes, 8 megawatt of power. That means obvious that is a problem. Not only, there is also the software that is behind. Our chair speakers spoke about cybersecurity, the possibility of attacking the grid. Also geopolitical factor that is influenced, because when you speak about new technology, and then you need the storage, because obvious that the storage is together with the renewable energy is the essential connection that we need. Together today, there is a lot of technology. The oldest one is the hydro pump. No? The biggest hydro pump is obvious that there are some pro and some cons. For sure, duration of the storage from an hydro is very important, because we have huge tanks with water. Then it's for sure have a possibility to accumulate the energy for a long duration. With the lithium systems that together is the major technology that used in the market in automotive, but also in the storage systems. This lithium and cobalt inside, as you know, the major part of this primary role is owned by China. That is creating other geopolitical problems. Today we are experimented our dependencies from the gas. We have a huge risk to have a dependency from China in the next future, because obviously that we are using these storage systems in the automotive, we are using this kind of storage systems in the grid for energy community, for stability. Obviously, there is a need for a new technology. Europe understood this one and launched an important investment. We are speaking about more or less 4 billion for new technology, also to optimize the present technology. This is the EPCI project, important project for common European interest. There is a different company that are now investing in this kind of technology. As one of these one is in Italy, is green energy storage, but we have other company in Holland as Elestor, or United States as Revenue. The common factor of this company is they are creating a new storage systems that are not using lithium. Is a platform that there is only one chemistry that will produce in the charging mode hydrogen, and then reuse this one. It's a closed system. So there is no, the hydrogen is developed only when the battery is working. That means that you don't need to buy hydrogen. You need only one chemistry. Elestor is using bromine as only one chemistry. Enel in the United States is using nickel. Green energy storage is a secret technology until now, because it's a patent. They are not only one, but are 2 or 3 new chemistry, green chemistry, that that is the density is not that is true for all kind of these new systems, is not the same of lithium. That means that is not useful for the automotive, but starting from the houses to the big systems, there is a lot of advantage. First of all, because there is as a flow battery that is an hybrid from a fuel cell and a flow battery. That means that the power is divided from the energy. The energy is the chemistry, is in the tank. You can have a large tank, then you have a long duration. That is very, very important. Last not least, also to build this kind of systems, the factory is very clean because there is no chemistry in the factory. Just you are assembling some components as a tank, as the stack that is membrane and the electrolyte for the storage, and in the rest the chemistry is fulfilled only when the battery is installed in the market. Last not least is also you take the advantage in terms of cost, because the cost is the other important component. Everybody is investing in hydrogen. That means that the expectation in the future that the cost of this battery will be reduced, and the number of the cycle, that is the other element of the storage, is very big. We are speaking about 10,000, 15,000 cycles. That means that so this kind of battery have a long duration in terms of the age. And if you see the cost, everybody speak about the cost for watt hour, but it's very important to have also the number of the cycle, because in this case the cost of this kind of a battery is less than the lithium battery. That means that in the next future, due to the fact that the necessity from storage will be huge, we expect to be also shortage in the market. That means that there is a space for all kinds of technology. But if you are now in the way, and you are now facing three kinds of issues: geopolitical issue, we are facing a technical issue because we need to accumulate energy that is unpredictable, and the other one is to reduce the cost. For the industry, because that is a competition in the market, and energy is an important part of this competition. There is some industry, mainly in the ceramic, paper, that depend iron, that depend a lot from the energy, that is important, the cost. For Europe, it's very important to develop their own technology, because without that, we have a huge problem, and then we pass from dependencies with Russia to dependencies with China. I don't know which is the best, but in any case, it's a trouble. In any case, it's a problem. I imagine a future that we have a big growth of the energy community, because everybody will try to develop their energy, and storage will be part of this one. I expect that you can imagine a huge development of a different kind of software to manage storage, software to integrate this software in the grid, software that will be in the storage, that mainly artificial intelligence software, and blockchain, in terms that you can close a contract directly. You accumulate or non accumulate, looking at the different elements. That means meteo or price or whatever. That is part of the knowledge base and the artificial intelligence software. I expect that will be in the future a new model, a new utility model. If you combine this one with IoT, with efficiency systems, you can imagine that you speak about a smart grid, you speak about a different kind of business model. That means that we have a huge opportunity, but we need to be also careful, because I'm a little bit worried about automotive area, because the big stop that Europe mainly launched to stop all fossils engine. If we have not the same development in the grid, sooner or later we have a problem to recharge this electrical car. It's not the case that the company as General Electric or Stellantis is now creating not only a charging point, but also storage systems behind, because obvious that the stress for the grid will become very important. If a large industry as automotive have a problem in terms of the consumer are not so comfortable to buy a car, because there is a lot of issue in terms of possibility to recharge their car, mainly if there is a huge percentage of the market, obvious that that is a problem. But I'm an optimist, because Europe is investing a lot of money in that. Utility understood that the future will be totally different from the actual present. We need the stability in the market, we need the stability in the price, we need the stability in the rules of the market, because this is another important issue. Without a clear rules that don't change, not be subjected at some influence, that's created the right environment to develop a new energy systems. Thank you very much.
Thank you very much, Salvatore Pinto, for your very interesting speech. I think you touched a very important aspect related to the clean energy transition. Certainly storage is part of it. So you underline not only the opportunity, but also some of the challenges to have some attention on raw material, not to base a new technology on something that is already bringing Europe in the same condition as today to be dependent on external countries that sometimes are not fully reliable. And you also touch important aspect, of course, briefly about the other aspect related to the clean energy transition. The cyber attack possibility was mentioned, and other important aspect related to electromobility was also underlined by you. I want to tell you that I feel that, of course, we have to work hard in order to make the electromobility, electrification of transport, a big opportunity for the system more than a challenge. But of course, we need to work hard in Europe to make this possible. And I would like to tell you that many actors in Italy are very active in this field, exactly to make this an opportunity with smart charging, vehicle-to-grid functionality to support the system more than bringing an additional stress on our system. So thank you. We didn't receive any question in the chat so far. Eventually I have one myself, but I wait till we have the end of this session. So can you see my screen now? I will be happy to introduce the second speaker. The second speaker is Massimo Salvetti, Grid Modernization and Innovation Director at CESI in Italy. And he will be speaking about the energy transition and the impact on grid security operation. Massimo, the floor is yours. You have 15 minutes, please.
Thank you, Luciano. I share my video.
Perfect.
Do you see my
yes,
video?
We can see,
okay.
We can hear very well. The floor is yours.
Okay, thank you. Okay. Yeah. Okay. Good morning. With this presentation, I will try to show you first overview about energy transition and the impact on grid security operation, where CESI as a consultant is involved. I am Massimo Salvetti, Director of Grid Modernization and Innovation Director, and we work worldwide in this field. The energy transition is changing in a short time. The mix of different production, and in particular from traditional concentrated resource to a mix between large scale power plant, the standard configuration, mixed with photovoltaic, eolic, distributed energy resource, storage, battery, electrical vehicle. A totally different situation that in particular for the distribution system is a new paradigm, because the distribution system is becoming an active system and not a passive system like in the past years. This is very important because now for the so-called defense plan analysis, we need to consider this different situation, because it's totally different study this kind of situation compared with the previous one. This new mix have effect in particular in the power balance and power flow in the network, in the control of voltage profile, and in the different grid inertia and stabilities. Very important is also the presence of renewable energy with discontinuity and no programmability that create a very huge problem for the security of the system, because without secure value, it's not possible to perform the standard methodology used to create the defense plan and the grid security operation. And so as an example to show you how this new mix have an effect in the field of security, I will show you how in the standard situation, for example, in this NSOE in the Europe network, the defense plans is based on SPS system. SPS is Special Protection Scheme or System Protection Scheme. These traditional SPS are characterized by offline simulation to evaluate the critical situation and to define the control action and the tuning of SPS. But now with a new mix of generation and new situation, is not so easy to define the critical scenario, because this critical scenario increase a lot due to the variability of the generation like photovoltaic and eolic. A first step to resolve this huge number of scenarios is to increase the number of simulation, like in the SA methodology that use a lot of simulation and a lot of data from the field to try to cover all possible critical scenario. But also in this case, it's not easy to check all critical situation in the network. To solve this, one actual used methodology is, for example, the use of one system and to avoid the simulation, the offline simulation. This is done because from WAMS it's possible to recreate the real situation of the system, but to do this we need to manage a lot of data and a lot of information, And with this, we are able to resolve the critical situation online, directly online, without a simulation. And we can act in a fast way, the solution and the control action with the trigger of SPS. Here we can see some real case that have the TSO in this system have changed the SPS with the new technologies, in particular with very new critical phenomena that appear in the new mixed situation, like angle instability and inter-area oscillation. In particular, in Europe, we find this new critical situation between the different parts of the network. For example, the scope of this SPS in Turkey is to avoid the loss of synchronism between Turkey and Europe, and to limit the transmission overload between Turkey and Europe. This is very important because it is the main scope of this SPS system is to avoid the opening of line between Turkey and Europe. Also in Italy, Terna is under development one system that have the scope to resolve the inter-area oscillation, because also here in Italy, between South and the rest of Europe, are the inter-area oscillation due to the reduction of inertia in the system caused by the presence of gear and the reduction of standard power plant have created inter-area oscillation that now we will try to solve with the WAMS system. As described for the SPS, the new defense plan will have to use the network digitalization and also a strong TSO-DSO coordination, without forgetting also the involvement of distribution generation in this important field. But to do this, it's important also to manage a lot of data, and this creates a complexity in the telecommunication infrastructure, because with a lot of data, we need a strong telecommunication to exchange this huge amount of data. That means that in the future, we need a new methodology also in the operation, linked with data analytics and machine learning, because also these two important methodology will be an help for the security of the system. With the digitalization, also the final consumer will also be able to participate in the network security. This means that also the distribution side will become very important in the security of the network. For example, with the use of demand response, we will be able to use the final consumer, for example, with the electrical vehicle in V2G modality, or use the resource from the consumer, like the switch on or switch off the thermostat, air conditioning, or many other kind of load. We are able to modulate the load and use this support in the field of defense plan. And the Internet of Things moved on also in our room. We make also as actor in the network security. But to do this, all this technology will be deployed in a smart grid structure. Here you can see a very complex model, is a NIST model regarding the smart grid logical model. And you see that all these standard common area like transmission, distribution, generation is linked with a telecommunication where we need to exchange data and information. This is very critical in the future, this field, because not only a large amount of data will be acquired, but also interaction among the different actors. And this creates probably a critical situation to create a trust change that cover all the link between the different actors. This means that the digitalization need the interaction between different gears, and in particular, big amount of data, and it's important to avoid the so-called data tsunami, because a lot of data can create a good representation of the network, but also without a good management of this data, you can have a problem to understand the quality of this big data. Other important gear of this interaction is the good procedure and process, because without a good procedure and process, you are not able to use in a good way this big amount of data. And very important, as discussed before, the cybersecurity, because with a lot of amount of data, a lot different channel of communication, the attack surface increased, and we need to have cybersecurity assessment, cybersecurity verification also in the field of operation of the grids, because as seen in this figure, in the last year, the cyber attack to the power grid infrastructure have increased. And this means that in the future, probably we need to take a look also in this important field, because a blackout created by a cyber attack in the future could be possible. And to be sure that to avoid cyber attack, also in the field of the operation of the network, we need these the 4 important steps for the cyber security. This means the cyber risk assessment to verify the situation of the operation, the cyber security procedure to create a good procedure, and cybersecurity audit and penetration test to check the network, if the network are in cybersecurity, and also the live monitoring and the incident analysis. But in the future, probably also in the operation, the good guideline is the security by design as used in the normal IT technologies, because in the future will be not possible to not consider the cybersecurity in the operation of the network. Thank you for your attention.
Thank you very much, Massimo. I'm very glad that you address the system as a whole. You were mentioning how the distribution system evolved, becoming more and more active, integrating most of renewable at that level. But you also mentioned how the transmission system is evolving and protecting itself. So you spend a few words on the protection system, on the challenges to keep the system fully functional over the different situations. I'm also glad that you made this important reference to digitalization. System digitalization is a very important aspect in these days. And also you made the point about the great amount of data we can have available. Nevertheless, nothing is becoming available for free. So we have also the challenge of cybersecurity. Thank you for addressing this topic that is fully in line with this session. So the important to protect our system against people attacking the system, also because we open up our system to connect the different, either a million of generation points, so you need to be sure that the protection of your communication channel is in place. So thank you. And thank you also to you and Salvatore for staying within the time. And now I'm ready to invite the next speaker to come on stage. And the next speaker will be Simone Botton, Head of Network Operation and Maintenance at Enel Grids. He will be speaking about resilience and emergency management in Enel Grids. So thank you for sharing this important approach from one of the big players in Italy. I think the floor is yours. You have 15 minutes. Thank you, Simone. The floor is yours.
Thank you very much, Luciano. I will share my presentation.
Please.
Okay.
It's a presentation mode now. Thank you.
Okay. Thank you very much. So as Luciano has introduced me, I'm Simone Botton, Head of Network Operation and Maintenance at Enel Grid. As you know, it's one of the biggest utility in the world. We are currently managing over 2.2 million kilometers of electrical network, low, medium, and high voltage network, distribution network, giving energy to over 75 million of customers, mainly in Italy and Spain, but also over other countries, Romania, Colombia, Chile, Peru, Brazil, and Argentina. So we have a big experience in different places and in different scenarios of managing distribution network. So in this presentation, I will briefly give you an overview on how we manage network resilience and emergencies. And as has been introduced before, we are facing big climate changes all over the world. Snowstorms, thunderstorms, floods, winds, heat waves also are becoming even more intense every year in all over the world. And as we are managing networks on different climate zone, we are managing those events all over the year, all over the time. Are unfortunate events, we have to face them in the best way possible. So we develop a strong strategy on resilience based on an approach that we call 4R. So the 4R are risk preventions, readiness, response, and recovery. What does this mean? First of all, risk prevention. We have to be ready. Our network has to be ready. We have to be ready. So risk prevention means a good asset management. Asset management means, first of all, taking into account of our experience and our data on climate impact on our network when we are designing the network, making a resilient design of the network, and when we are giving our standards for our components and material. So we are moving from some kind of designs to other kind of design, other kind of components. For example, the use of aerial cable instead of conductors, aerial conductor. This is very important, for example, in the zone where there are strong snowstorms. The aerial cables is less affected than the bare conductor. We use also, of course, new network, development of the network, refurbishment of the existing network is based on this kind of things, but it's also really, really important in this sense, the maintenance process we have. We are moving from a maintenance strategy based on preventive or on-condition maintenance to an approach based on predictive maintenance. What do you mean predictive? We are using our data, our sensors that are installed on the network, the signals that comes to the network, elaborating them, and also the elaboration of the environment in order to prevent, to give an idea to where to do a specific intervention of maintenance. This means be more effective and more efficient, and thus giving a better quality of service. For an example of what we are developing now as an innovation project is the vegetation management. Now the vegetation is managed on a preventive approach, on a periodical approach. We cut plants every year, every 2 years, every 3 years, depends on the environment, on the legal constraint, etc., the condition of the network, etc. Now we are trying to build a system together with other partner to manage, elaborate data from satellites, from the vegetation type, from the climate, etc., to detect how a tree, for example, is growing, how much is growing during the year. This means that we are going to manage this plant, to cut or prune this plant, not every year, but when it is needed, preventing falls and being more effective, more efficient on our activities. This is the risk prevention. Then, after talking about the network, we have to be ready to face the emergencies that unfortunately happens. This is doing, of course, by first of all the formation to our people. We have what we call an emergency academy. Well, we have different kind of academy. Unfortunately, we had to build also an emergency academy. We teach to our people, to our contractors, how to be ready to face an emergency. Then we have build some system. Later, I'll give you a short overview of the weather alerting. Some system that give us the idea that an emergency can occur in the future, near or far future. Thus, giving us the opportunity to reinforce our field force and to manage through our operative centers that are, of course, open 24 hours a day, every day of the year, the management of the field force and the network, maybe reconfiguring network, giving them a strongest configuration on the operation and being more resilient to what we think here is going to happen. We build a strong relationship with the public authorities in order to giving between them a mutual aid in case of emergency. We need the help of Protezione Civile in Italia when we are facing big snowstorms, as they maybe need our help if in case there is a situation where there needed emergency generation. So we build a strong relation with them, and this is in order to be more ready to respond to emergencies. Well, when happen an emergency, we need to be ready and quick to respond in an emergency. Later we'll go into detail, but first of all, it's very important our automation and telecontrol system that is installed on the network. The first steps of an emergency is to reconnect more users as possible through the remote control system. Because of course in an emergency it's very difficult to use field force, because maybe there are complex conditions where our workers cannot work to the network. It's important to remote control or all our operation, our lines that are along the territory impacted by the storms, by the climate events. We use task forces. Our organization, later we see also in recovery, is built to be flexible in order to give help in different areas, in the areas impacted by the event, from all the other areas that they are maybe available because they are not impacted from the event. So this gives us the possibility to be more quickly, more fast, and of course more effective in the response of an emergency. We also use new technologies, as later we see drones, emergency generators, backup cables, backup components, in order to be more effective and more quick on the response of that. After the first response in an emergency, of course, we have to recover of the network. This is done by our organization, which I said is resilient, the engagement of the customer, and the flexibility of our network. Of course, during an emergency, maybe we use backup components and provisional reparations that have to be rebuilt after that. We try to be as much as homogeneous in this approach in all the countries we are present. So we're trying to take a uniformity of approach, which for us is much more simpler and allow us to share the best practice along the countries. So this is an example of how is a typical behavior in terms of disconnected customers of an emergency. Every phase of an emergency has its main focus to deal with. The first, well, there is an emergency, so we have a peak of customer disconnected. As I said before, after that, it is important to be ready with our operative center, with the restoration of as much as possible network can be through automation and remote control. Here is when we activate the local crisis room, take contact with local authorities, give communication information to our customers, and begin our coordination with the institution in order to solve the problem faster as possible.
Simone, just to let you know that you have a couple of minutes left.
Yes, I know.
It can take a little bit longer, doesn't matter, but just to inform you. Thank you.
Yes. I go fast.
No, it's fine. Very interesting. Thank you.
After the first phase, it's important to recover with emergency generators, backup cables, etc. And then here is important the presence of our field force and the task forces that help them to make things more easier, more faster. I will give you two brief examples of the new technology. The first is of the readiness part. We built a system which is called weather alerting. It's an elaboration of different data, the hazard, the condition of the network, the weather that is expected, give us an idea, a score of what can be the risk in the next few hours. This allows us to be ready, more ready, to activate the task force, to reinforce our field forces, and etc. This is an AI system. It means that it will be better time to time that we use that, and substantially it improves every time there is an emergency or there's something, because with the AI system, of course, the results and the algorithm are slightly different than before. And then a short thing about the use of drones, which is very useful, particularly during the emergency. We use actually do a short range operation because of the local and the legal restriction. It's very useful, for example, where there is no or a part of our network is not accessible, but we are going to move forward to two kinds of operation, which are long range operation and a remote automated operation, which will allow us not only to be more faster in the response, but also in the preventive area, because it will allow us to do inspection and to look at our network in a very fast and very efficient way. Thank you very much. If you have any...
Thank you very much, Simone. And thank you also for really showing how an important organization like yours is taking countermeasure when extreme weather events appear in different parts of the world. And thank you for also let us know how you prepare yourself and your crew in order to intervene as fast as possible in order to put the system back in operation. This is very interesting. I think we didn't receive any question in the chat box. I have a couple of questions myself. One could be related to storage, and maybe Salvatore Pinto will be in the best position to reply. Is about some requests we receive at the international level about the importance of a long-term duration energy storage. So which are the technology, which is the real need? When we talk about long-term duration, we think about more than 8 or 10 hours, or something that cannot be obtained by regular electrochemical batteries. So if you want to spend a few words on that. And then I have another question that it will be really broad in terms of how important is digitalization, in terms of communication, in terms of new technology to allow the system modernization and decarbonization. And this I invite them after Salvatore, Massimo, and Simone to make some comment on that. So Salvatore first.
Thank you very much for the question. Well, it's exactly this the issue compared with the lithium and other technology. This is the reasons that Europe invested this money through the EPCI, and just a case of green energy storage. We are speaking about a flow battery that uses one chemistry. The flow battery have a peculiarity that is the energy part is divided by the power part. Yes. That you have the opportunity to enlarge the tank, and you have a duration of 10 hours. That is exactly where the biggest power plant, photovoltaic power plant, aeolic power plant needs. And that is the opportunity. Last not least, due to the fact that generally the flow battery have a not so big density, this new technology have the same density of the lithium of the first generation. That is enough, because obviously that the space is the other part. No? If you have a space, you occupy more lands, that's problems. But you can have also the opportunity to build up, to occupy the land also in high part, not only in one dimension. That is the huge opportunity. And the size of this market is around $60 billion.
A huge market.
The biggest market in energy sector in the next future.
Thank you for your excellent reply. The market you mentioned is huge. That's why also US DOE is investing a lot of this technology around the world to make example and demonstration and pilots on this. Thank you, Salvatore. So coming to digitalization, I know digitalization can be used for anything. We know that it's important for augmented reality to train the crew, could be also used for predictive maintenance or condition-based maintenance. So I'm asking to the expert, Massimo first and Simone, what do you think about which are the new trends or which are the new challenges, if you want to share with us your view? Salvatore, please.
From my point of view, digitalization is one of the pillars for the future, because without the digitalization, we will not be able to support the energy transition, because all this new technology will help us to integrate all the new elements like battery, like electric vehicle, and so. And without digitalization, we will not be able to perform this integration.
Excellent. Short answer, but quite clear how important is digitalization for the energy system transition. Thank you. Simone, do you want to share any important aspect about digitalization that is taking place at Enel grids?
The digitalization, as I said before, is really important to stay in the energy transition, but also to maintain and improve the quality of service in terms of customer side and safety to our customers. The main challenges, in my opinion, are two. One is the communication system, because all the system has to be integrated. The network, the electrical network, is everywhere in our lands, in our country. So also the sensors need, also the simplest sensor needs to be integrated in a communication system which is fast and reliable. And this is really a big challenge for us, because sometimes I have to build a new infrastructure, not only these things to use an existing infrastructure. So it's really different. And the second thing is the management and the elaboration of all the data that are collected to the network. Of course, a network which serves 30 million people, like the one we are managing in Italy, it means billions of data every year, maybe every year, every day, maybe every hour. So they need to collect it in a secure way, because the cyber security risk is really important, and to be able to elaborate them in efficient, in a thing that we are able to have significant result, and that help us to improve in our activities. That can be designing of new network, maintenance of existing network, or operation, day-to-day operation.
Yeah, I think I can now agree more with what you said. Increase or enhance observability and controllability of the system is important. You can do that by new sensor installed in the system. Also to control the state of charge, the state of health of important energy storage system in our grid. So this is part of the story. That's why I think all your contributions were fully in line with the session where we talk about grid security. Now that we have a massive integration of renewables, and now that we have all this complexity due to a huge number of generation unit spread across the country. I don't know, we have still 1 or 2 minutes left. I don't know if you want to make a final remarks, what still need to be researched or innovate from now on, because as you know, what we do in this decade is extremely important if you want to reach the net zero economy by 2050. So any good recommendation from you about what need to be innovated now in order to be ready for decarbonizing our system? Salvatore, one keyword from you, and then I go through the other speakers.
Continue to invest in research and development. We are just at the beginning of the revolution. Without investment in research, we lose, no win.
Thank you so much. Very sharp, very clear. Thank you. And Massimo, and a keyword from you.
Yes, I agree with Salvatore. We need to invest in the research, and we need also to invest in data management, because we are not so ready for this data tsunami.
So big data technology and everything related to.
Yes, data analytics, data-driven technology, and so.
Excellent. Thank you. Simone, final word from you.
Of course, I agree with Massimo and Salvatore on that, but I would like to add that we have to be, I think, more integrated, not only in the utility world, but also with the regulators, the research factories, and the authorities, etc. You want to build a future and to sustain the energy transition, we have to move it the same way everywhere, everything. Because if some parts of the long value chain, which is the distribution network, distribution transmission network, we can face a lot of difficulties.
Thank you very much. I would like to thank all the three speakers for their excellent contribution. I think what you put forward is very relevant for the evolution of our system. Thank you for your time. Thank you for being so specific on some important aspect. I thank you, all of you, and I thank the participants to this session. And I think we are ready to close. And thank you very much. Have a nice holiday season, all of you. Thank you.
Thank you.
Thank you. Bye.
Let's keep in contact. Thank you. Bye. Thank you.